Hi, my name is Atsushi Suzuki, and I am an optical engineer and technical liaison at Nikon. I would like to talk about the new Nikon Z mount and explain from a technical point what makes it so special. Nikon is well known for great lenses. Our company vision is to unlock the future with the power of light. We believe this new mount will help us achieve that vision. The introduction of the Z mount is very special because it combines so much experience and knowledge from many engineers and designers over the last 100 years. The new Z mount was developed for the new Nikon mirrorless camera and lenses, and it possesses huge potential in optical design. This mount design has two important factors. First, it has a 60mm flange back distance. Second, it has a 55mm inner mount diameter. These two dimensions give the new mount great advantages, such as the ability to support f1.2 and even f.95 aperture lens designs. I'd like to explain how designers decided on these specific dimensions. So why is the flange back distance 60mm? The flange back distance has been rigorously determined to allow maximum light from NIKKOR Z lenses to reach the sensor in the purest form possible. It is also understood the shorter the flange back distance, the smaller or thinner a camera system can be. Let me illustrate. This is the optical axis. It is the center of image sensor. This is the image sensor. And this is a lens. And this is the camera body. And from here to here, this is the flange back distance. So for our F mount, so this is a 46.5 millimeters. And our new mount, new Z system, the image sensor is here. And flange back is very short, 60mm. If the flange back is short, we can provide smaller and thinner camera. Of course, there are challenges to reducing flange back distance. For example, there are mechanical components on top of the image sensor that cannot be removed, such as glass filter, a mechanical shutter, and other components. This is one challenge that engineers faced in order to reduce flange back distance. In order to achieve the flange back distance of 60mm, Nikon engineers had to reduce the thickness of each of these components while testing for optical and physical precision in order to meet Nikon's high-quality standards. In doing so, engineers were able to reduce the flange back distance to 60mm and at the same time achieved a new level of optical performance. Next, why did engineers set in a diameter of 55mm? A large mount can capture much more light. So by making the mount diameter much bigger, the camera can capture a lot of light and engineers can design much faster and brighter lenses. But if the mount diameter is too big, then it is possible that the lens and camera body will also be too big. On the other hand, if the mount diameter is too small, smaller lens and camera body can be designed. However, only slow lens can be developed. Let me illustrate. So this is the optical axis and image sensor. This is a lens. And camera body. And this is a lens mount. And this distance is inner diameter, and this is ray. So, and this angle is F number. If this angle is large, the F number is fast, and if the angle is small, the F number is slow. And the mount diameter is small, we can develop the small lens and small camera system. So if mount diameter is big, we can develop the first F number lens. This angle is big, but the lens and camera body is too big. So now we develop Z-mount system. And this mount diameter is 55 mm. It provides the best balance of size and great image quality. For an FX format sensor, engineers understood it is important to have enough illumination or central luminous flux to produce a great image at fast apertures. As you saw, 55 mm was determined as providing the best performance with a 60 mm front-back distance on FX format sensor and the perfect balance to deliver the best optical image quality. Now, with the Z-mount, it is possible to provide extremely fast lenses such as f1.2 and even f.95. Also, 55 mm diameter offers a lot of flexibility in optical and lens design. For example, it allows the installation of the large lens element close to the mount, and it also allows space for a powerful actuator for the AF drive. Let me illustrate. This is optical axis and sensor. And this is lens. And this is camera body. This is lens mount. Our new Z mount has a big diameter. So we can put the big diameter lens across the image sensor. So with bigger diameter, we have a room here, and we can place the more powerful actuator, so for faster autofocusing. More space from the bigger mount diameter gives optical engineers the ability to design exciting new type of lenses. For optical engineers, such as myself, that is perhaps what is most exciting. Our engineers created a mount that is faster, allows for great new lens designs, and works perfectly for still photos or video. This new mount enables silent operation and smooth focus for video that professionals will enjoy. Since Nikon is so famous for NIKKOR F lenses, it was important to provide full compatibility with a wide range of lenses without any loss of image quality. This is done with Nikon's mount adapter FTZ, which provides the necessary front-back distance for NIKKOR F lenses. So, this is Nikon's future-proof mount design. It's the ultimate solution that supports high-performance lens design that capture a lot of light while reducing the system size and maintaining F-mount compatibility with the optional adapter. 55 mm inner mount diameter and 60 mm front-back distance, these may seem like just numbers, but together they result in endless possibility for optical design.